Hey guys, this is 12.4. Today we're talking about arc length and sector area. Okay, so just a reminder, the circumference of a circle is 2 pi r. All right, and the area is pi r squared. Okay, so you've probably done this before. Just a quick reminder on how to do that. Let's do a problem of that. So if we're trying to find the circumference, we have 2 pi, and then we're going to multiply it by the radius. So here it's 8. So that would give you 16 pi, and that would be your exact answer, okay? And this is, I guess, centimeters. All right, so this is exact. Kind of talked about that last time, is that we want to keep our answers exact. We could also, sometimes it's useful to do an approximate answer, so we would just do 16 times pi, okay? And that gives me 50.3 centimeters. Okay, so this is approximate. Okay, so make sure you read the instructions for your homework. I think it will probably ask you to find the exact answer. If it, I can't remember, I guess I could look really quick. Okay, so these are the homeworks. It does say exact answer. So please make sure your answers are exact. Okay, all right, so and then if we want to find the area, so area is equal to pi r squared, so that's 8 centimeters squared. Okay, so we square the 8, we square the centimeters, so we'd get 64 pi centimeters squared. Okay, and again, you could find the approximate if you wanted to. That'd be 64 times pi, and you'd get like 201.1 centimeters squared. Okay, so approximate answers are good, and we use that a lot in life, but just for us, for our class, we're going to try and keep our answers exact. Okay, so you could do B if you wanted to. I think your answers here would be 20 pi and 100 pi, and these would be feet squared, and this would be just feet. So if you want to give that a try, go for it. All right, so this is leading to what we're actually going to be covering. So looking at example 2a, what portion of the circle are you supposed to be solving for? So what is like that section that's kind of bolded? Okay, well here I would probably say it looks like it's a quarter. So 1/4. Okay, well, how do you get that? Well, we know, I don't know, there's a circle is 360, and this is maybe 90 over 360, and if you simplify that, that gives you 1/4. Okay, and that's probably how we'd probably want to do this. So let's try B. What portion of the circle are we supposed to solve for? So we can do the same sort of thing. We can do 225 over 360, and then we can just simplify that. Again, we can do this using our calculator, so 225 divided by 360, and then if you're using a TI, so here I end up getting 0.625, but we don't want decimals, so we need to do either your calculator automatically puts it in a fraction, or if it's a TI, you'd want to push math, which is kind of like right underneath your blue and green button on your calculator, and then the first thing is frac, and you'll choose that fraction, and I get 5/8. Okay, so just looking at this, you could probably figure it out. Like this is half of it. We could even put this into like quarters. Okay, so it looks like we have 1, 2, 3, 4, 5, 5 out of 8 sections. Okay, so that could be a possibility. Sometimes you could probably figure that out. Sometimes it's not as clear. Like, what if it goes by 6ths or 12ths? Then it's going to be a lot harder. So you might just want to do it like the fraction out of 260. Okay. All right. So using that, we are going to learn how to find arc length and sector area. Okay. So arc length, again, is just, it is the same as the circumference, but just part of it. Okay, so what's bolded here is just like the outside of the circle. That's our circumference. But we don't want the entire circumference. We just want the part of it. So same sort of thing. What we'd do is we'd maybe say, well, 300 degrees out of the 360, that's like the fraction of the circle that we want. But then we're going to multiply it by the circumference, which is 2 pi r. And here r is 2 feet. Okay, so a lot of this we could do in our calculator. The thing that we don't want to do is put the pi in there, because if you put the pi in, then it's gonna give us a decimal that never ends. So we want exact answers, kind of like we talked about before. So we could do 300, we could divide that by 360, okay, and then we can times it by 2 for this 2, and then we can multiply it by 2 again for that 2. And I end up getting a decimal. It looks like 3.33 repeated, but then we'd want to have it as a fraction. So we'd get 10 over 3, and we still have that pi. So 10 pi over 3. Okay, and that would be our exact answer for the arc length. And this is feet. Okay, so this is an exact answer. If you were to find an approximate, then you would just evaluate and have a decimal. So we could go back to that 3.33 that I had and then just multiply it by pi, or you could do 10 pi divided by 3. So I'll just do that just so we have an example of an exact answer. So I end up getting here is, this would be like approximately equal to, or maybe they do it like this, I think that's what they do. Approximately equal to 10.47, okay, feet. But again, today I'm going to be asking you to find the exact answers. So here is kind of like the formula for arc length, okay? So it's the fractional part of the circle. So if it's like 180 degrees is the part that we want, then that would be obviously like 1/2, because 180 over 360 is 1/2, okay? So we want a portion of the circle, and we'll multiply it by the circumference. Okay, so the one below, this one, this is what we would do if we were doing it in radians. Okay, so instead of dividing the angle by 360, because that's, if it's degrees, we divide it by 360, because that's the whole circle of in degrees. If we did radians, we would take that radian amount and we would divide it by the whole circle's radian, which is 2 pi. Okay, so we'll do an example of that too. Alright, so the first one is in degrees. So same sort of thing, we want to do the fraction of it, so 270 out of 360, and then we're going to multiply it by 2 pi r, so 2 pi, and here r is 8. Okay, we can evaluate everything, just keep the pi on itself, so we'll have pi over here, but then we'll do 270 divided by 360 times by 2 times by 8. So here I get 12 pi. And that would be your exact answer. Okay, if we wanted to approximate, we would just take 12 and times it by pi, and we'd get 27.7. Maybe we'll just round to the 10th place. Okay, oh, and this is yards. All right, next one. So this one's in radians. So instead of doing the angle amount divided by 360, we're going to do pi thirds, and we're going to divide it by 2 pi. Okay, and then we'll multiply it by the circumference, so 2 pi r, which here is 10 feet. All right, so what I would recommend here is that we have 2 pi on top and 2 pi on bottom, that we would just cancel those out, okay? And then we just end up having pi over 3 times 10 feet. and that's just 10 pi over 3. Okay, so that can't be simplified any further, and I think that's it. Okay. All right. So, and that's one thing that you can notice this for all of them, is if it's in radians, the 2 pi's will always cancel, and basically we can just do the angle times the radius. Okay, and that's typically how the arc length is written if it's in radians. But just to keep it all the same, I think I would just keep doing the same thing that we've done. All right, so now let's talk about sector area. So it's the same kind of idea. It's going to be a fractional part of the area this time instead of the circumference. So here we have an example where we have an angle of 45 out of 360. I mean, you can, looking at it right away, or maybe not right away, but this is like 1/8. It's an eighth of your circle, kind of like your pizza. Okay, so that's that, and then we'd multiply it by, instead of 2 pi r, we're going to multiply it by pi r squared. So it would be 12 meters squared. You're going to do the same sort of thing. We're going to keep that pi kind of by itself. We'll evaluate everything else. So we got 45 divided by 360, and then we're going to multiply it by 12 squared. Here I get 18 pi, and there'd be meters squared. Okay, so I think all of these have units. Make sure you include your units. Okay, so that would be the exact. The approximate, well, we would just do 18 times pi, and I get approximately 56.5 meters squared. Okay. All right, so here's kind of like the formula, same sort of thing. We have the fractional part, so these are like the fractions of the circle, or the area, or I guess it's a circle. Okay, and then we're multiplying it by the area. All right, so let's do one of each of those as well. So we've got the fractional part, so 120 degrees over 360, so that's like the fraction of the area. And we'll multiply it by pi r, and then we'll square it. So same sort of thing, 120 divided by 360. It looks like it's a third, so if you realize that, you could probably just go 1/3. Okay, and then we're going to multiply it by 16 squared. So this is kind of like what I type in. I do 120 divided by 360 times 16 squared. Okay, so that ends up giving me a decimal this time. So we'd probably want to make it be a fraction. So I got 85.33 repeated, but I'll do math frac, and it gives me 256 over 3, and again we have that pi, and we have miles here, so miles squared. Okay, and then this one, this is the trickiest part. Okay, so if we're doing it in radians, so either your choices are is that you could switch it to degrees, okay, but your answers, if it starts in radians, your answer should be in radians. So if you decided to switch it into degrees, that's okay, but make sure that when you're done you need to switch it back. Okay, so here again we're doing like a fractional part, so 5 pi over 3, and we want to know out of 2 pi. Okay, and then we're going to multiply it by the area, so pi r, which is 11 yards squared. So here we do have some pi's that are going to cancel. We could cancel that, we can cancel that. We could also instead cancel the 2 pi's in the fraction too. That would be fine too. Okay, but again we're going to save that pi to the end. So we're just going to look at the numbers. So we have 5 divided by 3. So that's what I would do, 5 divided by 3. And then that's being divided by 2. So we'd divide that again by 2. Okay, and then we times it by 11 squared. Okay, so this is what I typed into my calculator. I did 5 divided by 3, and then we're going to divide it by 2, and then we'll multiply it by 11 squared. So that's what mine kind of looks like on my calculator. Almost looks like a date. Okay, so it ends up giving me 100.83 repeated. Again, we want a fraction, so we'd do math frac if you're using the TI, and I would get 605 over 6. And then don't forget that we still have this pi. Okay? And that would be our answer. Let me know if you have any questions. I think that's about it. We could look at our homework. So this is our homework. Make sure that you're answering your questions and exact answers. So I think all of your answers, you don't need to come up with the approximate. Okay? And then just because, I don't know, I want you to have the good example of them, but if you have questions, please let me know. All right, maybe we can look at 13 really quick though. It says an analog clock, so that's the one that has hands, okay? Has numbers 1 through 12, those are your hours, okay? If it's exactly 1 p.m., so if we have a clock like this, if it's 1 o'clock, then the hour hand is at 1 and the minute hand is at 0, okay? So using that, what is the angle made between the hour and the minute hand? So what is this angle? Okay, so kind of think of like the fraction of the circle. Okay, if a circle is 360 and there's 12 hours in a circle on a clock, okay, what fraction of the circle, what is the angle made by those hands? Okay, so write down that in radians and degrees. And number 2 asks if the radius of the clock is 8 inches, what would be the arc length of the clock between those two hands? So what is this arc length here? Maybe I'll use red here. Okay, so what is this? And then using that same angle, what would be the sector area? Okay, so if you have questions on that, let me know. I think the answers are on the back for 13. So just make sure you understand it. If you have questions, please let me know. All right, we'll see you later.